All right, we've covered how to figure out how much a mole of any element weighs. That would just be its atomic weight from the periodic table. What if you have a compound made out of several different elements, right? A compound is at least two elements combined together. And it's simple enough because the mass of any kind of a molecule is just the mass of all the parts that make it up. For example, if we were trying to find the mass of a car and we couldn't weigh it, if we knew how much tires weighed, we could add the tires together, we could add the steering wheel together, and the weight of all the parts of anything will equal the total weight of that object. And it's the same in chemistry. If you have a molecule, its mass is going to be the mass of all the atoms that make up that molecule. So let's have a quick look at how we would find the molar mass of a somewhat complex compound here. And so what we would do is, if we were looking at this structure here, C2H5O2N, and we wanted to know how much a mole of glycine weighs, what we'd do is add up all the pieces of it. And here's a simple table you can fill in to keep track of your numbers. We have the elements that make up the molecule, and we need to know how many of each of those types of atoms are present, so that's the subscript, right? So we have C2, so we have 2 carbon atoms. We have H5, we have 5 carbon atoms in this molecule. We have O2, so we have 2, and we have 1 nitrogen. So this molecule is made of 2 carbons, 5 hydrogen, 2 oxygen, and 1 nitrogen. The next thing we need to do is find out how much each one of those elements weighs. And what we do is we would go to our periodic table and look for the atomic weight. All right, so if this is our symbol for carbon, it's element number 6. Its atomic weight is about 12.01, so we'd put in our 12.01 grams per mole. And then we'd find hydrogen element number 1, and it's about 1.01 grams per mole. And then find the symbol for oxygen element number 8, it's about 16.00 grams per mole. And then nitrogen is element number 7 with about 14.01 grams per mole. Right, and since this molecule contains 2 carbon, we have to multiply 2 by the weight of each carbon. And so we get 24.02 grams per mole from our 2 carbon atoms. We have 5 hydrogen, so we multiply the weight of 1 times 5. 5.05 grams per mole from the hydrogen in that molecule. We have 2 oxygen, so 2 times the weight of 1 is 16, so that gives us 32.00 grams per mole. And we only have 1 nitrogen, so we have 14.01 grams per mole. Then we just add these things all together and it gives us that total mass of the molecule, 0.07 grams per mole. So 1 mole of this molecule would weigh 75.07 grams, and if we had 75.07 grams of this molecule, we'd have 1 mole of that molecule. So then we could use that conversion factor with our mole map to convert grams to molecules, or grams to moles, and moles to molecules.